Suppose your, my set is this, a set of all cross and matrices over a field n in such a way that which are skew symmetric matrices and the entries, coming from 0, 1, 2, -1, 2, 3, like this. Yeah, what is the cardinality of this? Anybody? What is the cardinality of this?
5 power n into n minus 1.
Yeah, 5 power n into n minus 1 by 2. Yeah, is it right answer?
Yes, sir.
So, but there is some trick actually. Actually, look at that things. Actually, look at the elements in a possible set. What is this actually? What is a skew symmetric matrix? Diagonal elements are fixed by 0. Remaining entries, suppose you are given like here -1. So here whenever a12 entry is 1, automatically a21 entry should be -1. Whenever a1 went to a1 3 entries, suppose it is 2, a31 entry should be -2, right? But the thing is, here -2 is there in my set. -2 is there? No, right? No, right? So therefore the elements which are working, here is that only 0, 1, -1 only. 2, there is no -2. 3, there is no -3. Therefore, what are the possible elements of the given matrix? Only 0, -1. 0 plus 1 -1 only. So now what is the cardinality of S?
3 power n into n minus 1 by 2.
Yeah, this is what actually. Is it clear? So this is very, very important argument, right? So this 2 and 3 are not possible for the skew symmetric matrix, right? Suppose
నిన్న చెప్పిన దాంట్లో 0 1 ఉంది కదా సార్ సెట్
0 1 0 -1 లేదండి.
-1 లేదు.
Only 0 1 ఉంది సార్.
Yeah, -1 పెట్టుకోండి. అది యాక్చువల్గా -1 పెట్టుకోండి, because if there is no -1, there is no skew symmetric matrix.
Okay.
Okay. What is a symmetric matrix? Okay, for this question, what is suppose you take this set of all n matrices such that, what is a symmetric matrices? Suppose your Aij entry coming from 1, -1, 0, 2, 3. Yeah, now tell me, what is the coordinate of S? What is the coordinate of S? Anybody? Yes or no? What is the cardinality?
5 power n into n plus 1 by 2.
Yeah, that's it. There is no restriction actually. There is no restriction. Right? If you take -1 is here, automatically 1 is here. If you take -1 is here, -1 is here. Right? If you take 2 here, you take 2 here. Understand? Like this. If you take 3 here, automatically 3 here. So there is no problem with the symmetric matrices. So coordinate of S is 5 power n into n plus 1 by 2. But the only restriction for the skew symmetric matrix. So this is important idea. Right? Next is, I'm going to give a question for you. This question asked in CSIR June 2014. Look at your question paper. The June CSIR net June 2014. Look at question paper. Suppose A is a 5 cross 5 matrix. The real entries. Such that sum of entries in each row of A, is 1. Then sum of all elements of A cube. Answer A 3, answer B 15, answer C 5, answer D 125. Tell me, what is the answer? This question asked in CSIR. Anybody?
Five.
Five. Okay, good. Right. Suppose what is A matrix? A matrix is actually what? 5 cross 5 matrix. So number of rows are 5. Number of rows, of course, 5. Number of columns also 5. 5. Right. So already what you are given is the sum of entries in each row is 1. Therefore, what is the sum of elements in each row of A cube? What I require A cube. What is that? Anybody? Sum of elements of each row of A cube. What is this? 1 cube, right? I told you formula 1 cube. 1, right? Now sum of all entries, sum of all entries of A cube. I told you formula, right? Number of rows 5 into this sum. What is that? 5 is answer. So this question asked in CSA 2014. Look at your question paper. Okay, previous question. Next is that one. This question CSIR, again this question asked in CSIR June 2014. Look at a question paper. For a given matrix A power 6 is identity matrix. What is a suitable matrix? Cos pi by 4, sin pi by 4, 0, minus sin pi by 4, cos pi by 4, 0, 0, 0, 1. P is 1, 0, 0, 1, 0, 0, 0, cos pi by 3, sin pi by 3. Next 0, minus sin pi by 3, cos pi by 3. C is, my C is cos pi by 3, sorry, pi by 6, 0 sin pi by 6, 0, 1, 0, minus sin pi by 6, 0, cos pi by 6. T is cos pi by 2, sin pi by 2, 0, right? Minus sin pi by 2, cos pi by 2, 0, 0, 0, 1. ఈ క్వశ్చన్ వచ్చింది జూన్ 2014 లో. ఒకసారి వాట్ ఇస్ ఆన్సర్? ఎనీబడి? A power 6 actually is I and A power 6 is I, right? Suppose you take this A as a first option. What is I option? Cos pi by 4, sin pi by 4. What is this? Cos pi by 4, sin pi by 4, 0, minus sin pi by 4, cos pi by 4, 0, 0, 0, 1. Right? So is it option right? You need to check A power 6 is identity matrix. What is A square, anybody? A square is CS 0 minus S C 0, 0, 0, 1. CS 0 minus S C 0, 0, 0, 1. So therefore this into this. What is this? This into this. C square minus S, C square minus S square. Next CS SC 0, 0, right. Next minus SC plus SC, right? Minus SC plus SC 0. Next minus S square plus C square, right? Next 0, 0, 0. Next 0, 0, 0, 0, 0, 0, 0, 0, 0, 1. So cos square theta minus sin square theta. What is this? Cos 2 theta, right? 2 sin theta, cos theta, sin 2 theta. 0. This is cos square theta minus sin square theta. Cos 2 theta. 0, 0, 0, 1. So what you observe is, when you take k square, you're going to get, instead of cos pi by 4, you're going to get 2 pi cos 2 pi by 4, right? Instead of cos pi by 4, what you're getting when you take k square? Cos 2 pi by 4, sin 2 by 4, 0, minus sin 2 by 4, cos 2 by 4, 0, 0, 0, 1. Similarly, when you keep going on, what is a cube? What is a cube? See, this is as it is. CS 0. Tell me, what is CS 0? CS 0 minus S, C 0, 0, 0, 1. Yeah, what is a cube now? Yeah.
Sir,
Hello?
అది ఎలా రాసుకున్నారు సార్ ఒకసారి చెప్పండి.
No, this notation don't. That's only notation. C means cos. నేను పెద్దగా అవుతుందని చిన్నగా C అని పెట్టాను. హలో, నేను యాక్చువల్గా కాస్ అని రాస్తాను, బట్ కాస్ అని రాస్తుంది పెద్దగా బిగ్గా కనబడుతుంది కదా, సి అంటే సింపుల్గా ఉంటుంది కదా అని చెప్పి సింపుల్గా సి రాస్తాను. అర్థమైందండి? సి అంటే
ఓకే సార్.
కాస్, ఎస్ అంటే సైన్, 0 అట్లే ఉంటుంది, మైనస్ ఎస్ సి, ఇది 0, ఇది 0, 0, 1. సిమిలర్ ఇక్కడ కూడా అట్లా చేస్తారు, సి ఎస్ మైనస్ ఎస్ సి. ఓకే, ఇది క్లియర్? నేను ఏం చేయలేదు అక్కడ, జస్ట్ ఏంటంటే నోటేషన్స్ పెద్దగా ఉంటాయని, బిగ్ ఉన్నాయని చెప్పేసి చిన్నగా రాశాను అంతే. ఉన్నదాన్నే చెక్ చేస్తున్నా. ఏ పవర్ 6 చేస్తే ఐ దేనికి వస్తుంది? ఈ మ్యాట్రిక్స్కి వస్తా, లేకపోతే ఈ మ్యాట్రిక్స్కి వస్తా, లేకపోతే ఈ మ్యాట్రిక్స్కి వస్తా, ఈ మ్యాట్రిక్స్కి వస్తా, రైట్? వాట్ ఈస్ ద లాజిక్ బిహైండ్ దిస్? I'll tell you, right? So this is nothing but what? C into, cos 2 pi by 4, okay, cos pi by 4, right, minus sin 2 pi by 4,
sin pi by
and
4.
pi by 4. Next, cos 2 pi by 4, sin pi by 4, plus
sin 2 pi by 4,
sin 2 by 4,
cos pi by 4,
cos pi by 4. Next, 0.
0, 0, 0.
Here also 0.
next 0.
Yeah.
0. Here is 0.
సార్ ఇక్కడ 0 రాదు సార్.
No, sir.
0. No,
రాదు సార్, 0 రాదు సార్.
రాదా?
0
No.
plus cos pi 2 pi by 4 minus sin 2 pi by 4.
So 0, this cos 2 pi by 4. Tell me, cos 2 pi by 4.
ముందు మైనస్ సార్, మైనస్ cos 2
Sir,
pi
it is
by 4
Minus
minus
sin
cos
2
2 pi by 4, cos pi by 4.
Into
Right.
sin.
sin 2 pi by 4, sin pi by 4.
So this,
Next one.
this. That's it, right?
Next one.
This-
Cos
Sir, it's
pi by 4.
minus cos 2 pi by 4.
0 minus cos 2 pi by 4, sin kada?
Yeah, it's
Sin
not
pi by
cos.
4. Sin pi by 4. Okay. Now tell me. That's it.
Yeah.
Right? Next is
Yeah.
this one. This cos 2 pi by 4.
Yeah.
Cos pi
Into
by 4.
cos pi by 4.
Cos pi by 4.
Yeah, tell me. What is this?
0.
0. Next, 0.
So 0, 0, 1.
0, 0,
0, 1.
1.
You know, tell me, what is this? What is this?
We can use the formulas cos A plus B, cos A minus
Cos A
B.
plus B.
Yeah, tell me. What is this? Cos 3 by 4. What is
3
this?
pi by 4.
Cos?
Pi by 4.
Pi by 4.
What is this?
Sign sir.
Actually, it's sin kada?
Yeah.
That's it. Yeah,
That's
sin
right.
3 by 4. Sin 3 by 4, right?
Yeah.
Next, this is 0. Now, what is this? What is this? Yeah, started. What is this?
5 by 4.
What is this? Is there any formula for that? Is there any formula?
2 cos A, 2 sin A, cos A, sin B. Cos sin of A plus B minus sin of A minus B. Minus
Yeah.
half.
So, but the thing is it any formation? You know, actually, the thing is it so? Does you get this minuses? Minuses? Yeah. Look at it. So this is what? Sin of A plus B. Half of sin is A plus B. Next. Yeah. Tell me.
Minus sin of
A minus B.
okay. Sir.
Question is, does you get the same argument here? Actually, ఇక్కడ మీకు ఏదైతే sin minus sin pi by 4 ఉందో అదే వస్తుందా ఇక్కడ?
No, sir.
No, sir.
రాదు కదా,
Plus.
రైట్? Alright, it's 0, right? So implication correct చేసామండి. Just go through this. 0 0 minus right. So 0, this 0, this is minus cos pi by 4, cos 2 pi by 4 minus sin pi by 4, 0, right? But the thing is, same thing you are not getting, right? You're
A square के second row first element difference వచ్చింది. Yes, sir.
a square కు same you know same ఉంటది కదా. యా 0 వచ్చింది కదా ఇక్కడ, 0 వచ్చింది కదా.
Different వచ్చింది A square కి.
యా a square 0 వచ్చింది కదా.
But the option ఏమో సార్ sum of అన్ని ఎలిమెంట్ sum of 1 అయింది.
So just cross check it. So a is equals to cos pi by 4. Yeah, this okay. 0 0 0. Okay, this is one way, but the thing is I'm going to follow second method. Trick behind this.
అన్ని సేమ్ ఉన్నాయి సార్, అన్నిట్లో ఒక మైనస్ సైన్ ఉంది.
Therefore sin pi by 2, that is minus a2. Okay, next, what is a cube even? Minus a2. That means what is minus a2? Sin pi by 4 even plus cos pi by 4 e2. Okay, next, what is a power 4 even? Minus sin pi by 4 a1 plus cos pi by 4 a2, right? Therefore, what is even? This sin pi by 4. What is a power even? A even, sorry. What is a even? So cos pi by 4 even minus
Sin pi by 4 e2.
Cos pi by 4 even minus sin pi by 4 e2. Next, plus cos pi by 4. What is e2? Minus sin pi by 4 minus sin
Cos pi by 4.
Cos pi by 2 or cos pi by 4? Sin pi by 4 even plus cos pi by 4 e2. Is it right? Up to this step, is it right?
Yes, sir.
Yes, yeah. So here minus cos pi by 4 is cos pi by 4, because sin pi by 4 cos pi by 4, cos pi by 4 sin pi by 4, therefore cos minus sin a plus b. This is pi by 2 even. Next, this is sin pi by 4 sin pi by 4 minus cos pi by 4 cos pi by 4. What is this? Cos a plus b, right? Minus of cos a minus b. Yeah?
Cos a minus b.
So minus common cos a minus b means what? Cos 0. That is nothing but e2. Is it clear? So this is minus come. So this is plus. Yeah, go through it. This is plus, right? This is plus. Yeah, simplify it. Don't do direct. So this is nothing but what? Plus sin pi by 4 sin pi by 4 e2 minus so minus and minus plus again here, cos pi by 4 cos pi by 4.
Minus is minus plus.
Yeah, minus and plus. This is minus. Here this is a minus. Yes or no?
Minus second step minus cos pi by 4.
minus of a2 is nothing but minus of this. a2 minus చేసానా రాంగ్ చేశాను కదా, a2 ప్లస్ కదా. పైకి చూద్దాం. వాట్ ఈస్ a2? a2 what is a2?
Plus,
This one, right?
plus
Plus
only.
కదా, this is plus. So ఇది ప్లస్ అంటే ఇది మైనస్. Okay, go through the calculations. So this is minus, right? e2, right? This is nothing but what? Minus sin pi by 2 even. What is this? Minus of
Pi by 2 E2.
cos pi by 2 e2. So again this is 0, nullified. It's nothing but minus even. So thing ఏంటంటే యాక్చువల్ గా, so therefore next time వస్తాం e power 5 even. That means what? Minus a even. That means what you're going to get? So what you're going to get, a even cos pi by 4 even. So ఈ పైకి పోయి కిందికి రావాలంటే కొంచెం టెక్నికల్ ప్రాబ్లం. cos pi by 4 even minus sin pi by 4 e2. cos pi by 4 even minus sin pi by 4 even, right? e2, sorry. Next a power 6. ఇక్కడ మనకి ఈవెన్ రాలేదనుకోండి, దిస్ ఇస్ నాట్ a suitable answer. That's what argument. a1 plus sin pi by 4 a2 cos pi by 4. What is a1? What is a1? Cos pi by 4 even minus sin pi by 4 even. Next, what is a2?
E2. Sin pi
What is
by
a2?
4 E2.
Yeah, sin pi by 4 a2. Sin pi by 4. What is a2? a2. Now let's start like. What is a2? Sin pi by 4 even plus is good to sin pi by 4 even plus sin pi by 4 even plus cos pi by 4 e2. Now tell me, Amma. So even. So therefore, what you're going to get? Minus cos pi by 4 minus sin pi by 4 even. Next, plus cos pi by 4 sin pi by 4 plus
sin
sin
pi
pi
by
by 4 cos pi by
of
e2. Yeah, ఇక్కడ చెప్పండి యాక్చువల్గా ఏమొస్తుందండి. సో దిస్ ఇస్ cos of a plus b. సో దిస్ ఇస్ ఈవెన్. సో ఇది సూటబుల్ ఆన్సర్ కాదు, ఎందుకంటే ఈవెన్ నలిఫై అవుతుంది. ఈవెన్ నలిఫై కావద్దు కదా. సో దిస్ ఇస్ నాట్ మై సూటబుల్ ఆన్సర్. సో sin of pi by 4 minus pi by 4 plus pi by 4 e2. So this is nothing but what you're going to get? This is e2 only, because sin pi by 2, this is 1, this is 0. So a power 6 of e1 cannot be even. So this is not my answer. Is it clear? మనకి ఏం కావాలి? ఐడెంటిటీ కావాలి కదా. a power 6 ఐడెంటిటీ కావాలి కదా. అంటే a power 6 ఐడెంటిటీ అంటే a power ఈవెన్ రావాలా. Is it right? Is it clear the idea?
Okay, sir.
So this is an argument. So general procedure చేసే కంటే ఇది చేస్తే బెస్ట్. జనరల్ ప్రొసీజర్ ఫాలో చేస్తే కంటే ఈ ప్రొసీజర్ చేస్తే మీకు ఈజీగా ఐడియా వచ్చేస్తుంది. సిమిలర్గా ఈ ఆప్షన్ చెక్ చేయండి, సిమిలర్గా ఈ ఆప్షన్ చెక్ చేయండి. సో ఇట్ టేక్స్ టైం. సో సిమిలర్గా ఈ ఆప్షన్ చెక్ చేయండి, సిమిలర్గా ఈ ఆప్షన్ చెక్ చేయండి. ఇది క్లియర్? చెక్ చేద్దామా, చెక్ చేస్తారా?
No, sir. You can verify.
సో దిస్ ఇస్ ఇంపార్టెంట్ ప్రాబ్లం. ఇంతకుముందు సిఎస్ఆర్ జూన్లో వచ్చింది, ఇది కూడా 2014. ఒకసారి చెక్ చేసుకోండి. ఓకే, నెక్స్ట్ ఏంటంటే ఇంతకుముందు వచ్చిన క్వశ్చన్ ఇది కూడా వచ్చింది, చూసుకోండి. సో ప్రాబ్లం నెంబర్ 4, ఇఫ్ ఏ అండ్ బి ఆర్ మ్యాట్రిసెస్.
ఆన్సర్ ఏంటి సార్ ఇంతకి?
ఆన్సర్ ఐ థింక్ సి. ఆన్సర్ ఐ థింక్ సి. నేను యాక్చువల్లీ చెక్ చేయలేదు దీన్ని, బట్ ఆన్సర్ ఐ థింక్ సి. ఆన్సర్ సి. ఇక్కడ యాక్చువల్గా ఏంటంటే 6 years ఏమొస్తుంది చెప్పండి. 6 years ఏమొస్తుంది చెప్పండి. a power 6 అంటే ఇక్కడ ఏమైతే 6 వస్తుంది, 6 cos pi వస్తుంది. cos pi అంటే -1 ఇది కాదు. సో ఇక్కడ 6s ఏమొస్తుంది 3 pi వస్తుంది. 3 pi అంటే ఇక్కడ 5 వస్తుంది. ఇక్కడ 6s ఏమొస్తుంది 2 pi వస్తుంది కదా. cos 2 pi అంటే 1. ఇక్కడ చేస్తే ఏమొస్తుంది sin 2 pi వస్తుంది 0. ఇక్కడ 6s ఏమొస్తుంది sin 2 pi 0. ఇక్కడ చేస్తే 6 ఏమొస్తుంది cos 2 pi వస్తుంది. సో 1. సో దిస్ ఇస్ ఆన్సర్. సి కాదు బి. బి ఇస్ ఆన్సర్. 6 చేయండి ఇక్కడ 6 6 6 6 6 years ఏమొస్తుంది cos 2 pi. cos 2 pi is nothing but 1. So 1 0 0 0 1 sin 2 pi is 0. Again this 0 sin 2 pi is 0. cos 2 pi is 1. Therefore 1 0 0 1 is nothing but I. Is it clear?
Okay, sir. Okay, sir.
But the thing is ఇట్లా చేయకండి. ఇట్లా చేస్తే మీకు ప్రాబ్లం లెంత్ చేస్తుంది.
వాల్యూస్ సబ్స్టిట్యూట్ చేసి చేయడం ఈజీగా సార్.
డైరెక్ట్ చేయడం అనేది అట్లా చేయొద్దు. అండర్స్టాండ్? డైరెక్ట్ అట్లా చేయొద్దు. ఎందుకంటే ఇది యూలర్స్ ఫార్ములా కాదు కదా డైరెక్ట్ చేయడానికి. యూలర్స్ ఫార్ములా అంటే e పవర్ θ cos θ ప్లస్ i sin θ అంటే జనరల్ గా మనం ఏం చేస్తాం e పవర్ i θ అంటే హోల్ పవర్ 5 అని అనుకోండి. cos 5 θ ప్లస్ i sin θ ఏం చేస్తాం కదా. బట్ ఇక్కడ డైరెక్ట్ అట్లా చేయొద్దు. డోంట్ డూ డైరెక్ట్ లైక్ దట్. ఇది మీకు ఈజీ. యాక్చువల్గా ఇక్కడ ఏంటంటే మీకు ఏంటి పేజ్ ఎండ్ అవుతుంది కాబట్టి లెంత్ కనబడుతుంది. బట్ ఇట్లా వేస్తే మీకు 2-3 స్టెప్స్లలో ఆన్సర్ వచ్చేస్తుంది. 2-3 స్టెప్స్ అంతకంటే ఎక్కువ ఉంటుంది. 3 స్టెప్స్ అట్మోస్ట్ 6 స్టెప్స్ మాక్సిమం 6 స్టెప్స్. సిఎస్ఐలో మనకు ప్లెంటీ ఆఫ్ టైం ఉంటుంది. 3 hours ఉంటుంది కాబట్టి ఈజీగా చేయొచ్చు.
ఓకే.
ఇది కంప్లీట్ గా చేసి పెట్టండి మేడం. ఎవరైనా గ్రూప్ లో పెట్టండి కంప్లీట్ సొల్యూషన్.
యా
దట్స్ గుడ్. టైం
సింప్లిఫికేషన్ ఏమి ఉండదు. A1 యూజ్ చేయండి ఈజీగా వచ్చేస్తుంది. నెక్స్ట్ ఇది కూడా వచ్చింది ఇంతకుముందు. సో మ్యాట్రిసెస్ ఆఫ్ సేమ్ ఆర్డర్. జనరల్ మల్టిప్లికేషన్ చేస్తే ప్రాబ్లం వస్తుంది. ఎప్పుడైనా జనరల్ మల్టిప్లికేషన్ చేయొద్దు మ్యాట్రిక్స్ లో. సో దట్ ప్రాబ్లం అంటే సింప్లిఫికేషన్ బిగ్ అవుతుంది అంతే, ఏం లేదు. AB is equals to BA. Then option A is diagonal. Option B, A is diagonal and B is any matrix. What is my C? A and B are both diagonal. What is C? Sorry, this is B. What is C? A is a scalar. B is diagonal. What is D? None. Yeah, tell me which answer is right. So first option check చేయండి. A diagonal B any matrix అంటే చెక్ చేయండి. A diagonal అంటే check the first option. Diagonal అంటే you can take this 1 2 0 0. B equals to suppose AB equals to BA కదా, right? Suppose you can take what options you are going to take. ఏం తీసుకుంటారమ్మా? 1 matrix multiplication commutative కావాలి. What is answer? What is the matrix? How can you take the matrices? Matrix multiplication commutative కావాలి కదా. ఏదైనా ఒకటి తీసుకోండి, చెక్ చేయండి. I don't know whether they are working or not. 1 2 1 0 this 1 0 0 0 this. So what is this? 1 1 0 1 0 0 0 0 0 0. Right? Is it right? 0. Right? Next is what is BA? 1 0 0 0 0. Right? So matrix multiplication is commutative. Okay, but the thing is ఇక్కడ ఏమంటున్నాడు? B is any matrix అంటున్నాడు కదా. What is that? B is any matrix అంటున్నాడు. A diagonal అన్నాడు. సో కమ్యూటేటివ్ అయినప్పుడు A diagonal అయిద్దా అన్నాడు. A diagonal B any matrix కావచ్చా? థింక్. కమ్యూటేటివ్ అయినప్పుడు A diagonal B any matrix అంటున్నాడు. Is it true actually?
No.
Is it true? In general, is it true?
No, sir.
ఏ డయాగనల్ కాకుండా ఏమైనా కమ్యూటేట్ అయ్యే ఛాన్సెస్ ఉన్నాయా? ఎనీబడి? ఏ డయాగనల్ కాకుండా బి ఎనీ మ్యాట్రిక్స్ కాకుండా కమ్యూటేట్ అయ్యే ఛాన్సెస్ ఉన్నాయా?
No, sir.
లేవు సార్, లేవు.
No, sir. matrix multiplication is not.
Suppose I can take this sum. నేను b ఈక్వల్స్ టు 0 మ్యాట్రిక్స్ తీసుకుంటాం. a ఇంటూ b ఏమైతే చెప్పండి 0 వస్తుంది. b ఇంటూ ఏమొస్తుంది చెప్పండి 0 వస్తుంది కదా. మరి ఏ డయాగోనల్ అవుతుందా? ఎస్ నో? ఏ డయాగోనల్ అవుతుందా?
No, sir. No, sir.
సో ఆన్సర్ దిస్ ఇస్ నాట్. సో వాట్ ఈస్ ద ఐడియా? యూ కెన్ టేక్ a ఈక్వల్స్ టు 1 2 3 4, b ఈక్వల్స్ టు 0. సో ab 0 అవుతుంది, ba కూడా 0 అవుతుంది. therefore they are commutative. But the thing is a is not diagonal matrix. Yeah. Now look at option b. Option B and actually A and B are both diagonal matrices. Already I told you diagonal matrices are always commutative. Diagonal matrices are always commutative. You take A 0 0 B, B is equals to C 0 0 D. What is AB? What is AB? AB 0 CD. So this can be written as BA 0 0 BA BA. Sorry, this is A. What is this? You can take C. Rotation, yeah, multiplication AC kada. AC BD. Wrong AC. Yeah. AC BD. What is this? This C D A 0. Therefore, this is nothing but what? The DA. Why this is true? Because these are the real scalars. So once they are real scalars, automatically R is a field. So therefore, it is commutative ring with unity in which every non-zero element is inverse. So therefore, it can be AC can be written as CA. So therefore, this is always true. AB is equals to BA. So this answer is right. Diagonal matrices are always commutative. Next is A is scalar matrix, B is any diagonal matrix. Is it right? Yeah, is it right? Yeah. A scalar matrix anta, B diagonal matrix anta. Is it right? A
Both are
scalar
diagonal.
matrix 0 0 A.
Yes,
B
sir.
you can take C D 0
Yes, sir.
D. Automatically true. Yes or no? Automatically
Both
true.
are diagonal.
So that is the power of scalar matrix. So AC 0. So this is 0 A, right? So 0 0 0 AD. Right. Next, what is BA? C 0 0 D and A 0 0 A. What is that? CA 0 0 DA. So these both are equal, right? Why? Because AC equals to CA. So therefore, scalar matrix with a scalar matrix, this is also true. Not only B is diagonal. See, B need not be diagonal. You can take any scalar matrix. You can multiply with any matrix automatically. That is commutative. AB equals to BA. Right? So what are the answers? B and C. What are the answers? B and C. Yeah. Next is this question asked in JAM. Next question. Problem number. Question asked in JAM. Suppose you can take A and B are matrices. B two matrices. N cross N matrix. Consider the following statements. Consider the following statements. Right? First is trace of A B is equals to trace of BA. Second one, trace of A plus B is equals to trace of A plus trace of B. So which of the following is true? Answer A. Answer 1. A only. Option 2. B only. Option 3. Both A and B. Option 4. Neither A neither B. Neither A nor B. Yeah, tell me.
Both are true, sir.
Both are true. Right. So this question asked in JAM. Already told you properties. Already I told you properties. Trace of AB is equals to trace of BA. This is right. And trace is linear. Trace is linear map. Trace of A plus B is equals to trace of A plus trace of B. So this is also right. Therefore, answer A and B both are right. So what is option? Option 3. Option 3. Next, this question also asked in John. Suppose A is equals to 2, 0, 3, 5 can be represented as P plus Q, where P is a symmetric matrix. Where symmetric matrix and Q is a Q symmetric matrix. Right, which of the following is correct? This question asked in John. So option A, Q is equals to 1 by 2 minus 3 by 2, 3 by 2, 0. Option B, Q is equals to 0, 3 by 2, 3 by 2, 0. Option C, Q is equals to 1 by 2, 0 minus 3, 3, 0. Option D, Q is equals to 1 by 2 into 2, 3, 0, 5. So tell me which answer is right?
C, sir.
Yeah, I don't know. I'll check. Okay. So, any matrix, any square matrix can be represented as a sum of symmetric matrix and skew symmetric matrix. Yesterday I told you, I did not tell you, I forgot to tell you this property. Any square matrix, I forgot it to tell you this property. Any square matrix can be represented as a sum of symmetric matrix and skew symmetric matrix. Right? Any sum can be represented as a sum of like this. So this can be represented as, this can be written as half into 2A, half into, this can be written as A plus A, that can be written as A plus A transpose, adding and subtracting A transpose. So this can be written as A, half of A plus A transpose plus half of A minus A transpose. Any matrix, square matrix can be uniquely written as a sum of square matrix and skew symmetric matrix. Yesterday I told you that this is a symmetric matrix. We have seen actually. We have seen any matrix, square matrix, you take A plus A transpose is a symmetric matrix, half into A plus A transpose also symmetric matrix. Yesterday we have seen this matrix is skew symmetric. We have seen this is skew symmetric, but it is unique representation. So already in a problem, it is represented as B plus Q. A is represented as P plus Q. Already in a given a problem, it is represented as P plus Q. So by unique representation, P must be equals to this. Q must be is equals to this. A minus A transpose. But you are required to find Q. What is Q? A minus A transpose. What is A? What is A? 2035. 2035 minus 2035. So half of, what is this? 2 minus 2, 0. 0 minus 3, minus 3. 3 minus 0, 3. 5 minus 4. 5 minus 5, 0. So this is the answer. So half of minus 3, 3, 0. Yeah, this is right.
Options లో ఒకటే skew symmetric ఉంది సార్.
ఇది ఒకటే ఉందా? 0. Yeah, ఇది ఒకటే ఉంది కదా? ఇది ఒకటే answer right. So that is right. Okay, so it can be represented as, so this is very, very important property. You need to write it. Okay, this is very, very important. Note, any square matrix can be uniquely represented as a sum of symmetric and skew symmetric matrix. Skew symmetric matrix. So this is very, very important fundamental statement. Okay. Right. Next is next concept. Hermitian matrix. Right. A square matrix, it is a square matrix it is Hermitian if and only a power theta is equals to e. That means conjugate transpose is itself. Conjugate transpose is itself. So that is same as saying that, you know, a bar. So this is exactly same as saying that we need to write like this. You know, what is a theta? Transpose of conjugate is equals to this. That means if and only ijth entry of this is equals to ijth entry of this. This is true for every ij. That is, you know, ijth entry of transpose is nothing but jth entry of a bar. So jth entry of a bar is nothing but, you know, conjugate of, this can be written as conjugate of jth entry. This is true for every ij, right? So therefore, you know, in particular, you can take the diagonal elements. So what you observe? So diagonal entries, you know, what is this? Actually, this tells you that diagonal entries are real entries. Understand? So in Hermitian matrix, all diagonal entries are, you know, z bar is equals to z. Means what? It tells you that the z is a real number. Here, aij bar is ai bar is equals to ai. Therefore, the ith entry, that means diagonal entry, are the real entries. So in Hermitian matrix, so what does it mean by this? Note 1, property 1, you know, all diagonal entries of Hermitian matrix are real. Suppose you take this example. You take 1, 2 minus I, no, 2 plus I, take the conjugate, take the real number. Is it Hermitian? The answer is yes. What is a theta? A theta is nothing but a bar whole transpose. That means what is a bar? Already told you, a bar is nothing but 1 bar, 2 minus I bar, 2 plus I bar, 2 bar whole transpose. That means 1 bar is nothing but 1 itself because 1 is a real number. This 2 minus I bar is nothing but what? Conjugate of this is nothing but 2 plus I. Conjugate of this is nothing but 2 minus I. This is 2 itself transpose. But this is exactly same as saying that 1 transpose 2 plus I.
2 plus I, 2
2
minus
minus
I.
2. This is 8. Therefore, it is Hermitian. Suppose you take this 1 plus 2i, 2 minus I, 2 plus I, 2. Is it Hermitian? Is it
No,
Hermitian?
sir.
No.
No.
Why?
Diagonal elements are real entries.
Yeah, good. So diagonal entries are must be, you know, they must be diagonal entries must be real number. So at least one entry is pure, you know, it is imaginary. So therefore, hence it is not Hermitian. Not Hermitian, right? Suppose you take this a equals to 1, 1 plus I, 2 plus I, and next you take into conjugate 1 minus I, 2, 1, 2 minus I, minus I, 4. Now tell me, is it Hermitian?
Yes.
Yes. 1,
No.
no, 1 minus I. What is the conjugate of this? 1 minus I. What is the conjugate of this? 2 minus I. Yes or no? What is the conjugate of this? 1
1
plus I.
minus I.
plus I,
What is the conjugate of this? 2. What is the conjugate of
2.
this? 1. What is the conjugate of
1.
this? 2 plus
2
I.
plus I,
What is the conjugate of this? I.
I.
What is the conjugate of this?
4.
Is it A? Is it A or not A? A itself, right? A
Yeah.
itself. So this is 1, right? What is this? No, I missed something. You know, conjugate of this is nothing but 1. Conjugate of this is nothing but 1 minus I. Conjugate of this is nothing but 1. Conjugate of this is nothing but 1 minus I. This is nothing but 2 minus I. This is nothing but 1 plus I. This is 2. And this is 1.
It's not A, sir.
It's not A, right? So therefore, it is not Hermitian.
అంటే 1 place లో I పెట్టుకోండి second row third element.
Not Hermitian. Because it is fails to satisfy this. You know, this entry and this entries are not equal. So therefore, it is not Hermitian. Okay. Now look at the properties of Hermitian. Suppose you take any square matrix, right? You take look at A plus A transpose. Is it Hermitian? Is it Hermitian? A plus A theta. A plus A theta. Is it Hermitian?
Yes.
Yes, sir.
Yes. Straightforward. Right? It is straightforward. So matrix. So it is S. Next. Suppose you take A is a Hermitian. Question is, if you take K is any scalar, you take any K is any scalar for a field F, does it mean that is KF KA? Is it Hermitian? KA?
Sir. Yes.
Yes or no?
Yes, sir.
Yeah, look at the possibilities. Suppose you take this K equals to I.
Sir, only real entries. K is equal to real entries.
Yeah, that's what point, right? So if you take K equals to I, K into F whole transpose is equals to what? You know, this is I A whole theta. That means what is I bar A theta? That means I bar is nothing but what? Minus I. This is nothing but A itself. So this is not same as saying that matrix itself. You know, what is this? This is nothing but minus K into A. Minus K into A. So therefore, this is not matrix itself. Therefore, it is not Hermitian in the case of imaginary, purely imaginary, right? If you take K is purely imaginary, you take K equals to purely imaginary, where K equals to I alpha, where alpha is a real number, what happens? Alpha is non-zero in particular, right? So therefore, what you get, K into A whole theta is equals to, that means, what is K? You know, this is K bar into A theta. K bar is nothing but I alpha bar A theta. I alpha bar is nothing but I bar into alpha bar into A, right? I bar is nothing but minus I. Alpha bar is nothing but alpha. Alpha is a real number. This is A. So this is same as saying that minus K into A. So therefore, K A whole power theta is equals to minus of K A. Therefore, it is not Hermitian. That means what you conclude? It is not Hermitian. Not Hermitian if this K is purely imaginary. And this is my first case. What is my second case? What is my second case? If K is purely real, suppose you can take alpha is a real number, or else you can take directly, you can take this itself. K is a real number. What happened? K whole theta is equals to K bar into A theta, but K bar is nothing but K itself because K is real. K is real, therefore K bar is K, therefore K into A, therefore it is Hermitian. Whenever K is real, it is Hermitian if K is purely real. Right? Next.
Negative number unte sir.
లేదు నెగిటివ్
K is-
ఉన్నా నథింగ్ ప్రాబ్లం. K equals to -1 ఉన్నా ప్రాబ్లం లేదు. Understand? K is any real number. Yes or no? If you take K equals to -1, if you take K equals to -1 into A whole theta, what is this? -1 whole theta bar, -1 whole bar into A theta. -1 whole bar is nothing but -1A because -1 is a real number. Yes or no? Therefore, -1 A theta is equals to -1 into A. Same matrix వస్తుంది కదా. Therefore, it is Hermitian. See, this is K is any real number. You can take K equals to -1, K equals to 2, K equals to 3, K equals to 4, anything. Any real number you can take. So it is Hermitian. The next possibility ఏంటి? Suppose K is complex number. Any complex number of the form A plus IB. Suppose you can take K equals to A plus IB, where A comma B are the real numbers. What about this? What about the K into A? Anybody? K into A is nothing but, what is this? K bar into A theta. What is K bar? A plus IB whole bar into A. But A plus IB is nothing but A minus I into A. Question is that, is it equals to A plus IB into A? Need not be, right? Need not be. In general, they are not equal. When do you say that they are equal? When do you say that they are equal? You know, 2B is equals to 0, right? Minus B equals to B. That means 2b equals to 0. That means what? B equals to 0. So whenever b equals 0, this k is real number. In general, this result may not hold. We have to hear this may not hold. A minus ib into a equals may not equals to a plus ib into a. But this can be equal whenever b equals to 0. But whenever b equals to 0, k is a real number. Therefore, in general, k into a, whenever k is a complex number, may not be Hermitian. May not be Hermitian. So k into a is Hermitian whenever k is a real number. Whenever k is purely real number. Is it clear? Hello, is it clear? Okay. Okay. So therefore, suppose me git లిచర్ అనుకోండి ప్రాబ్లం సపోజ్ యా ఏదైనా ఒక ప్రాబ్లం చెప్పండి సపోజ్ యా నెక్స్ట్ చెప్తానండి ఇప్పుడే వద్దు రైట్ సపోజ్ యూ కెన్ టేక్ దిస్ ప్రాపర్టీస్ అయిపోయింది సపోజ్ యూ కెన్ టేక్ దిస్ if a and b are Hermitian problem a and b are Hermitian question is that first question does it mean that a plus b is Hermitian? Does it mean that a minus ib is Hermitian? Does it mean that ab plus ba Hermitian? Does it mean that a transpose Hermitian or else a theta is Hermitian? Does it mean that ab minus ba is it Hermitian? Next, aba is it Hermitian? bab is it Hermitian? Right? Next is integral multiple a square is it Hermitian? A cube is it Hermitian? Or you can take in integral multiples is it Hermitian? Yeah, look at the first question. And does it mean that AB, this is also important, AB product, is it Hermitian? So look at first one, is it Hermitian A plus B? Yes, A plus B whole theta is equals to A theta plus B theta, but A is Hermitian, B is Hermitian means A plus B, therefore it is Hermitian. Next, A minus B, is it Hermitian? Yes, A theta minus B theta, this is nothing but A minus B, therefore it is Hermitian. What is AB? AB whole theta is equals to B theta into A theta. But B is Hermitian, therefore this is nothing but B, this is nothing but A. But question is that, is it equals to AB? No, right? In general, they may not equal. But if you provide, in general, this is no. In general, this is no. In general, but if you provide AB equals to BA, if you provide AB equals to BA, it is Hermitian. If the matrices are committed to, then it is Hermitian. Otherwise, it will not be. Is it clear? Is it clear? Hello?
Okay, sir.
Now question is AB plus BA, is it Hermitian? AB whole power theta plus BA whole power theta, that is equals to B power theta, A power theta, that is equal that plus A power theta, B power theta. That means BA plus AB, straightforward. So it is Hermitian. Is it is? Next, A theta whole theta is equals to what? A itself, right? But A is Hermitian, therefore this is A power theta. Therefore A power theta is always Hermitian. It is S. A theta whole theta is equals to A, but A is nothing but what? A is Hermitian. Therefore A theta is equals to A itself. Therefore it is Hermitian. But what about AB minus BA? This is AB whole power theta minus BA whole power theta. This is also straightforward. B theta, A theta minus B theta, A theta. But this is nothing but BA minus B. What is this? This is AB, right? So therefore A minus B. So in general, this is may not be, this AB minus BA whole theta is equals to BA minus AB. So in general, this may not equals to AB minus BA. Is it right or not? Right? So therefore, in general, this is no. In general, this is no. Right? But it is Hermitian if you take this. It is Hermitian. This is equals to what? This is equals to AB minus BA, provided it is equals to AB minus BA. But this happens, what is this? 2AB minus 2BA is 0. That means what? AB minus BA is 0. That means what? AB equals to BA. That means it is a zero matrix. So in general, this result may not hold, but the thing is whenever AB minus BA equals to 0, that means AB equals to BA, but this answer is okay. Understand? Whenever AB equals to BA, what is this? Zero matrix. Zero matrix is always Hermitian. Understand? Right? So in general, no, but in some cases AB equals to BA, automatically it is Hermitian. Right? So next AB whole ABA. But what is this? A theta, B theta, A theta. But that is nothing but ABA. So therefore it is Hermitian. What is BAB? Automatic same condition, because after all dummy with things. Next, what is A square? A square is always Hermitian, because A square can be written as A into A, but this is nothing but A power theta into A power theta. This is nothing but A into A. Therefore A square, it is Hermitian. Now what about A power K? A power K also Hermitian, because A into A into A into A whole power theta. This is nothing but A theta, A theta, A theta, but A is Hermitian. A into A into A into A. How many times? K times. This is A power K. Therefore product of Hermitian is always Hermitian. Integral powers of Hermitian is always Hermitian. Is it clear?
Okay.
Next, suppose you can take this set of all n cross n matrices. Suppose you take A power theta is equal Hermitian matrices, where the entries are coming from 1 plus I to 1 minus I. Yeah. What is the cardinality of this? Tell me. What is the cardinality of this? Anybody? Suppose you take any matrix. What is the form of this? What is the form of this? So these entries are diagonals. So they are fixed, you know. These diagonal entries are fixed because diagonal entries must be, you know, real number. Only thing you need to do is you need to fill up the upper elements of the diagonal, right? You know, it can be filled by, you know, how many choices for this element? A12, A13,
Two choices.
A1n. You know, there are, you know, how many choices?
Two choices.
How many choices? 2 choices or 3
Two.
choices?
Two, sir.
2 or 3? 3,
Three,
right?
three.
3, right? 1 plus I, 1 minus I, 2. Therefore, 3 choices. This entry, 3 choices. This entry, 3 choices. So how many choices for this? 3 into 3 into 3 into 3 into 3. That means what? How many 3s? N minus 1 3s. So 3 power n minus 1. Similarly, this is A2, 3, A2n. So A2, 3 also 3 choices. A2n also 3 choices. So 3 into 3 into 3 into 3 into 3. That means what? 3 power n minus 2. Going on. Here, there is n minus 1 n. How many choices? 3 choices. So total cardinality of S is nothing but 3 power n minus 1, 3 power n minus 2, 3 power 1. That means what? 3 power 1 plus 2 plus 3 plus n minus 1. That means what? 3 power n into n minus 1 by 2. Is it clear? Hello?
Okay,
Yes,
sir.
sir.
Yeah, ఇదే ప్రాబ్లం నేను ఎట్లా ఇచ్చాను అనుకోండి. సపోజ్ యూ టేక్ దిస్ S is equals to set of all n cross n matrices. Suppose you take this A theta is equals to A, where the entries are coming from, you know, 0 2 0 2 or 0 1 0 2 1 plus I. Now tell me, what is the cardinality of S? Or 1 minus I, 2 plus I. ఇప్పుడు చెప్పండి అమ్మ. So my set is this one. My set elements are coming from 0 to 1 plus I, 1 minus I, 2 plus I. Now tell me, what is the cardinality of S? Yeah.
n square plus 3 power n into n minus 1.
Yeah, we'll see. You know, already I told you, you know, the diagonal elements are real entries. That is care, you know, that you need to careful about the diagonal entries. So whatever you take, actually diagonal entries are filled by only real entries. A11, A1, A22, A2, ANN. So what? How many possibility for diagonal entries? Anybody?
2 possible.
Two possibilities.
2 possibilities. So 0 2.
0, 2.
2
So
power
therefore 2
that?
possibilities. 2
power.
possibilities. 2 power n. So for diagonal entries, 2 power n. Okay, good. Next, what about the remaining entries?
5 sir. Total 1, 2, 3.
How many possibilities for each entry?
Four possibilities.
Yeah, very good. Who said 4 possibilities? Name?
Chandra, sir.
Yeah, Chandra, very good. You know, this element is not work out because actually there is no conjugate of this 2 plus I. There is no 2 minus I. There is no 2 minus I because when you feel 2 plus I somewhere, you need to feel 2 minus I below the diagonal. But there is no 2 minus I. Therefore, 2 plus I is not possible. Is it clear? If you feel 2 plus I for some element, you need to feel 2 minus I. But there is no 2 minus I, right? So therefore, 2 plus I is not possible. So what is possible? What are the possible elements? 0. What are the possible elements? 0, 2, 1 plus I, 1 minus. So how many choices? 1, 2, 4 choices. This is 4 choices. This is 4 choices. So what is this? 4, 4 and minus 1. Next, A2, 3, A2, 3, A2, 4, A2, N. How many choices? 4, 4, N minus 2. What is this? 4. So what is the total? You know, work is completed. Therefore, what is the cardinality? These are diagonal entries. You need to fill it. Next, 4, 4, N minus 1, 4, 4, N minus 2, 4. Therefore, 2 power N into 4 power N into N minus 1 by 2. Right? That is 2 power N into, this is 2 square. Therefore, 2 power N into N minus 1. That is equals to 2 power N square minus N plus N. That means what? 2 power N square. Is it clear? Hello?
Yes, sir.
So this is important, right? See, look at the total possibilities. మీకు 100 ఇచ్చినా అందులో 100 మనకు పనిచేయవు. అది ఇంపార్టెంట్. 100 ఎలిమెంట్స్ ఇచ్చినా 100 ఎలిమెంట్స్ మనకు అందులో అన్ని పనిచేయవు. సో కాంజుగేట్ ఉన్నాయి పనిచేస్తాయి. అండర్స్టాండ్? ఆ సెట్ లో ఏముండాలి? కాంజుగేట్స్ ఉండాలి. అన్ని కాంజుగేట్ 1 ప్లస్ ఐ ఉంటే 1 మైనస్ ఐ కంపల్సరీ ఉండాలి. 1 మైనస్ ఐ ఉంటే 1 ప్లస్ ఐ కంపల్సరీ ఉండాలి. 2 ప్లస్ ఐ ఉంటే 2 మైనస్ ఐ కంపల్సరీ ఉండాలి. అట్లాంటి ఎలిమెంటే పనిచేస్తాయి. మిగతా ఎలిమెంట్స్ ఉన్నా మనకు పనిచేయవు. కాబట్టి దట్ ఈస్ ద ట్రిక్ బిహైండ్ ద ప్రాబ్లం. ఓకే, నెక్స్ట్ ఈస్ ఇప్పుడు ఇదే ప్రాబ్లం ఇది ఇచ్చాను. నెక్స్ట్ యూ కెన్ టేక్ దిస్ Skew Hermitian. Yeah, Skew Hermitian means you start with a square matrix. A Skew Hermitian if and only A bar theta is equals to minus A. That means if and only A bar transpose of a conjugate is equals to minus A. Transpose of a conjugate is minus A. That is if and only ijth entry of the conjugate of the transpose is equals to ijth entry of this one. This is true for every I. J. That means ijth entry of the transpose is nothing but jth entry of this. That is ijth entry, jth entry of the bar is equals to jth conjugate of the jth entry. This is true for every ij. So in particular, I can take what about the diagonal entries? Diagonal entries satisfy this condition for every I. That means z bar is equals to z minus z. What does it mean by this? What does it mean by this? Z bar is equals to minus z. What does it mean by this? AI can be purely imaginary. Yes or no? AI can be purely imaginary. Understand? It can be 0 also, including 0. 0 కూడా కావచ్చు. 0 bar is equals to minus 0 అని రాయొచ్చు కదా. సో ఇంక్లూడింగ్ 0 లేకపోతే 0 అని సపరేట్ పెట్టుకున్న ప్రాబ్లం. సో ప్యూర్లీ ఇమాజినరీ ఆర్ 0 మీ ఇష్టం ఏదైనా కావచ్చు. ఇది క్లియర్? డయాగనల్ ఎంట్రీస్ ఏం కావచ్చు అండి? జెడ్ బార్ ఇస్ ఈక్వల్స్ టు మైనస్ జెడ్ అంటే ఏంటి? జెడ్ ఏం కావచ్చు? ప్యూర్లీ ఇమాజినరీ కదా. ఇస్ ఇట్ క్లియర్? సో డయాగనల్ ఎంట్రీస్ షుడ్ బి ప్యూర్లీ ఇమాజినరీ. నౌ టెల్ మీ వాట్ ఆర్ ద ఎగ్జాంపుల్స్. సపోజ్ యూ కెన్ టేక్ దిస్ a is equals to 0, 2 plus 3i, 2 minus 3i, or else you can take this minus 2 plus 3i, 0. Yeah, what about this? A theta? What is A theta? 0, 2 minus 3i, because the conjugate is 2 minus 3i. What is the conjugate of this? This 0. right? It can be represented as minus common 0, 2 plus 3i, minus 2 plus 3i, 0. This is nothing but minus. Therefore, it is skew Hermitian. It is skew Hermitian. Right? Suppose you can take this same example. Suppose a equals to I 2 plus 3i minus 2 plus 3i. This is nothing but 2. Is it skew Hermitian? Is it skew Hermitian? I told you that diagonal entries are purely imaginary. Is it purely imaginary? Not purely imaginary. It's a real number. So therefore, it is not skew Hermitian. Right? Next, if you look at the sum properties, what about the diagonal entries? First property, diagonal entries of skew Hermitian are purely imaginary. Are purely imaginary. See, including 0, because 0 can be also purely imaginary, can be treated as a purely imaginary. Right? Next, you take A is square matrix. What about A plus A theta? What about A minus A theta? What about this? What about this? You know, A plus A theta is nothing but what? A theta plus A theta whole theta, but that is nothing but A theta plus A is nothing but A plus A theta. Therefore, it is Hermitian, not skew Hermitian. What is A minus A theta? Is nothing but A theta minus A. Therefore, this can be rewritten as minus A minus of A minus A theta. Therefore, it is skew Hermitian. Next is you take constant multiple. You take A and B are skew Hermitian. So, loss of generality, you can take only one metric. Skew Hermitian. What is, if you take any scalar, what is KF? Scalar multiple. Is it skew Hermitian? Anybody? If you take first, start with a real number. Take real number. K is purely real number. First case. What about K into A theta? That means what? K bar into A theta. But K is real number. K bar is nothing but K. A theta is nothing but minus A. Therefore, minus of Ka. Therefore, in whenever K is real number, it is skew Hermitian. Skew Hermitian. If K is real. Next, second case. Take K is purely imaginary. Alpha is a non-zero number, in particular excluding 0. If you take K equals to 0, it is skew Hermitian. It can be treated as skew Hermitian. If you take K equals 0, what is K into A? 0 matrix. 0 matrix is nothing but skew Hermitian. So take remove 0. Right? So K into A whole power theta. That means K bar A theta. That is nothing but what? What is K bar? I alpha bar. This is minus A. It is nothing but what? I bar is nothing but minus I alpha bar into minus A. That is nothing but what? I into alpha into A. It is nothing but K into A. So therefore, is it actually skew Hermitian? No, because K theta, K into A whole power theta is equals to Ka, but this is not equals to minus of Ka. Therefore, it is not skew Hermitian. K into this, not skew Hermitian.
సార్ కే ఇది రియల్ నెంబర్ అయితే చూడండి సార్ కే రియల్ నెంబర్ అయితే అక్కడ
K whole power theta is equals to, this is a formula already I told you. This is a formula, is or no? K into A theta K into A whole power theta is equals to K bar into A theta. But K bar is nothing but K ne, ఎందుకంటే K real కదా. Z bar is equals to Z whenever Z is real number.
Yes, sir. A power theta
is equals to minus A because I start with A. What is my A? What is my A? My A is skew Hermitian, right? So
Yes,
A theta is equals to
yes.
minus A.
Okay.
So therefore, this is nothing but not skew Hermitian. Or else you can take K is a complex number. A plus IB, where A comma B are real numbers. That is K into A theta. What is k into a theta? K bar into a theta. That is nothing but what? A plus ib whole power minus a. That means a minus ib into minus a. That is nothing but what? Minus a plus ib into a. So this is not precisely k into a, right? What is this? Is it minus of k a? Is it minus of a plus ib into a?
No.
No, sir.
No, right? So therefore it is not skew Hermitian. Therefore it is not skew Hermitian. So whenever k is a complex number, it is not skew Hermitian, right? Next is look at the algebra. Look at algebra. So suppose A and B are skew Hermitian. What about A plus B? What about A minus B? What about A plus B? What is A into B? What is AB plus BA? What about AB minus BA? What about ABA? What about BAB? What about powers? In general, A power K. Right? Yeah, these are the things. Now tell me, what is A plus B? A plus B whole theta is equals to A theta plus B theta, but A and B are skew Hermitian. This is minus A minus B. It is nothing but minus of A plus B. So it is skew Hermitian. What is A minus B? Nothing but A theta minus B theta, but this is nothing but minus A plus B. But this can be rewritten as A minus of A minus B. Therefore, this is also skew Hermitian. This is also skew Hermitian. Right? Next, what is this? A into B? AB whole theta is equals to B theta into A theta. This is minus B. This is minus A. Right? This is nothing but BA. But this cannot be minus AB. In general, this is no. In general, this is no. But if you provide BA equals to minus AB, that means A and B are anti-commutative. In general, no. But if you provide A and B are anti-commutative, then it is yes. A and B are anti-commutative. Is it clear? In general, no. But if you provide A and B are anti-commutative, it is yes. Is it clear?
Yes, sir.
It's also straightforward. This is nothing but AB whole theta, BA into theta. That is nothing but B theta, A theta plus A theta, B theta. Now what is this? This is minus B, minus A. This is minus A, minus B. But this is exactly same as saying that AB plus BA. Right? In general, it is no. It is Hermitian. It is Hermitian, not skew Hermitian. Yes or no? AB plus BA whole theta is equals to AB plus BA. Therefore, it is Hermitian. But in general, it is no. It is no skew Hermitian. It is not skew Hermitian. It is Hermitian. But if you provide AB plus BA is equals to minus of AB plus BA, then it is skew Hermitian. Same trick. Right? Is it skew Hermitian? AB theta minus BA whole theta. That means B theta, A theta minus of A theta, B theta. That is equals to minus B minus A. Next, minus A minus B. That is equals to BA minus AB. That is equals to minus of AB minus BA. So it is skew Hermitian. What is ABA? A theta, B theta, A theta. That means minus A minus B minus A. That means minus ABA. So it is skew Hermitian. It is also a same thing. What is A square? What is A square? A square whole theta is equals to A into A whole theta. That means A theta, A theta. There is nothing but minus A, minus A. So that is nothing but A square. This is not in general minus A square. But if you take A square is equals to 0. You take A square is 0 matrix, it is Hermitian. In general, it is no. What is A cube? This is nothing but a theta whole cube, same thing. But what is a theta? Minus a whole power 3. That means what? Minus a cube. Therefore, it is s. What you observe? What you observe? So in general, when you take a power k theta is equals to what is this? A into a this whole theta. That means a theta, a theta, a theta. It is nothing but minus a, minus a, minus a up to k times. That means minus a whole power k. That is equals to minus 1 whole power k into a power k, a power theta. Right, a power k. Right? That is nothing but what? This is equals to whenever k is odd, this is nothing but what? Minus 1 into a power k. Whenever k is even, this is nothing but what? A power k. Therefore, a power k, whenever k is a natural number, is Hermitian or skew Hermitian according to k is even, k is odd. Right? K odd in అనుకోండి skew Hermitian. K even in అనుకోండి Hermitian. A power k. Suppose a square ఉంది అనుకో k even కదా Hermitian. A cube ఉంది అనుకోండి skew Hermitian. A power 4 ఉంది అనుకోండి Hermitian. A power 5 ఉంది అనుకోండి skew Hermitian. Is it clear? Hello? Okay.
Yes, sir. Yes, sir.
A is Hermitian. A square plus IA 1/2 into a. Yeah. 2 into a plus 100 into a cube. Right? Yeah. Now tell me, see, minus of ఇంకోటి తీసుకుందాం minus a IA. Question is it Hermitian? Is it Hermitian? You know it is Hermitian. A square, it is Hermitian. Yes or no? Whenever a is Hermitian, a square is Hermitian. Yes or no? This one, this one. 2a also Hermitian, right? Because k is a real number. It is Hermitian.
Not Hermitian, sir, total.
A cube is Hermitian. Scalar
Yes.
product real number is Hermitian.
Yes, yes. IA
What is
not
this? What is this? Is it Hermitian?
No,
Is it Hermitian?
no.
So this is nothing but what? I. This is nothing but minus a, right? No. So this is nothing but minus IA. Is it yes or no? Yes, right? Yes, right? Minus I theta is IA theta is equals to minus IA. Yes or no? Therefore, it is so it is minus a kada, a only kada. So therefore it is not skew Hermitian. It is not Hermitian. It is not Hermitian.
Hermitian.
Now tell me total. What happened? Total for total. Total Hermitian idda ఇప్పుడు చెప్పండి.
Not Hermitian.
Not Hermitian. Why? Because if it is Hermitian, suppose it is B. It is B is Hermitian. B minus this total, this sum is Hermitian. This sum you can take suppose H. H is Hermitian. So B minus H is always Hermitian. Because whenever A Hermitian, B Hermitian, A minus B Hermitian. So here B Hermitian, suppose you assume that it is Hermitian. You assume that it is Hermitian. Already you know that H is Hermitian. This bracket term, it is Hermitian. What about B minus H? It is Hermitian. What is B minus H? Minus IA. It is Hermitian. Question is it Hermitian? I minus IA? No. Minus IA, it is not Hermitian. It is not Hermitian. Therefore, conduction. What you assume? You assume that B is Hermitian is wrong. Therefore, B must be not Hermitian. Is it clear? Hello?
Yes, sir.
Yes. Next. Suppose I take a set of all skew Hermitian matrices. Tell me, what is the coordinate of S? What is the coordinate of S? If you take an element in S, the S should be in a form of like this. And now tell me, what is the cardinality of S? So this A11, A1, A22,
4
diagonal.
power n into 4
This-
power n into n
N.
minus 1 by 2.
Now look at the nature. You know, what are the possibilities of diagonal entries? Two choices, because this diagonal
Four
entries are filled by
possibilities
only
are there.
purely imaginary. This diagonal entries can be filled by only purely imaginary. Therefore, it has two choices. This also diagonal entry, therefore it is filled by two elements, therefore it has two choices. Therefore, it has two choices. So for diagonal entries, it has 2 power n choices. What about the non-diagonal entries, which are sitting in the upper diagonal, upper elements? So therefore, what about this A12, A13 going on A1n? So many choices for this? Anybody? 4 choices. I minus I, 1 plus I, 1 minus I. So 4 choices. For this 4 choices. For this 4 choices. So 4 power n minus 1 choices. This is A23, A22, A2n. So many choices? 4 power n minus 2. This is 4 choices. So what is total? What is total? Diagonal entry is 2 power n into 4 power n minus 1, 4 power n minus 2, going on 4 power n. That means 2 power n into 4 power n into n minus 1 by 2. That means 2 power n, 2 power n into n minus 1. That is 2 power n square. Is it clear? Right? Is it clear, Amma?
Sir.
Next. Suppose I just change this problem. Set of all skew Hermitian matrices of order n by n, where my ijth entry 1 plus I, 1 minus I, 5 plus 3I, 5 minus 3I, next 2 plus 3I. Yeah, what is the coordinate of S? Anybody? What is the coordinate of S?
Zero, sir.
0. Good. Who said? Who said?
Snehalata, sir.
Yeah, Snehal, very good. You know 0. Why? Because there are no purely imaginary numbers, right? So there is no, suppose you take a skew Hermitian matrix. What about the diagonal entries? Diagonal entries are filled by, must be filled by purely imaginary, right? But in these elements, there is no purely imaginary numbers. In these elements, in these 5 elements, there is no purely imaginary numbers. Therefore, diagonal entries cannot be filled by any entry. Therefore, skew Hermitian matrices cannot be formed. Therefore, coordinate of S is 0. Is it clear? Right? Is it clear or not? Hello? Is it clear or not?
Okay, sir.
Yes, sir. Yes, sir. Yes.
So with this I conclude. Okay. Any doubts?